Well, hello there. Got here just in time. Well, I've actually been messing around trying to get things working for a while. First check is audio okay? Audio is going to be a bit of an issue today because I need to be walking around the room and I'm connected by a cable to the computer right now. Ah, fantastic. Thanks, Larry. So, sounds like it's working all right. That's good. Alrighty, so one other thing. There are so many ways this is going to go wrong today, which will make it more interesting. Firstly, I need to be able to show you different things around the room because I want to show you the pick and place machine. So you can see over my shoulder there is a tripod that's actually got my mobile phone on it, so which is streaming as an IP camera. So if I switch to that, we can stream from there, and then I can carry it around the room and hopefully show you different things, not just show you the fixed perspective coming out of the built-in camera in the computer. But so that could go wrong. There's also a little bit of lag on that, which is annoying. So if I'm facing that camera and talking to you, my lips will probably be out of sync. Ooh, Unexpected Maker says he's pick and placing tiny picos. Awesome, Sion. So he's got his machine going. His is a proper CNC machine. Mine is a homebrew Frankensteinian monster, as you'll see in a minute. And that may well go wrong as well. In fact, one of the reasons I was a little bit late starting today is that I've been trying to get the motion controller working on it properly, because there was a problem where if I needed to do either a pick or a place, what you need to do is move the head to the correct location and then lower it. What would happen is it would trigger those two events at the same time, so the head would be lowering as it was moving and it would crash into things. So I just got that working right before coming online. So, oh, Sion, yeah, so that from the IP camera, that is my phone. What is it? It's a poker phone, F1. So it's just using an IP camera streaming program running on the phone. But the thing is that I'm going to have to move a bit. So actually, let's do this as a test. I'm going to take this microphone and the other thing is you might hear a bit of a high-pitched squeal. I'm just going to be quiet for a second and see if you can hear this. That is the stepper motors on the pick and place machine. They just sit there squealing, which is kind of annoying. Oh, good, you couldn't hear it. The frequency is probably too high. So if I leave the microphone on the bench there and then go for a walk over here, let's see, the VU meter is still picking me up. Hopefully you can still hear okay. So if that's all right, I can walk around the room and Scott Miller says my pick and place is a Agoot TS15. So there was also one other thing. Mike says yes, the buzz is there. Well, hopefully it's not too bad. I'll keep the microphone away from the machine while I can. So one other thing that I was going to do before starting the live stream, and I didn't, was to paste up a board. So the this is going to be quite boring. I didn't get it done first, so I'm going to begin that. I might as well get that underway, get as much of it done as I can before everybody gets bored. So part of the problem is that the board we're going to be pasting up today is this one, which has a lot of placements on it. We're not going to be placing everything on the machine today. This has 103 1K resistors on it, so we'll place those. It has some 4K7 resistors. One of the interesting things about this board is that it's extremely repetitive. It's basically just lots and lots of the same thing repeated over and over again. Which when you're doing hand placement actually isn't too bad, because it means you can get into a flow. You don't need to think about what parts you're putting down. You can just keep using the same thing. but for more complicated boards that have a lot of different parts, that's actually where pick and place can be really useful, because you don't have to engage your brain. Once you've got it set up and it's putting the right parts in the right places, it'll get it right every time. So that can be a real help. But now I have to paste this board up, and I don't have a stencil for it, which is really annoying. So what I'm going to do is put it all on with a syringe. Now, if this was actually in production, what we would have is a stencil that you lay over this, and then you use a squeegee and put solder paste onto it, lift the stencil off. That means you can do a whole board like this in a few seconds. Instead, it's probably going to take me 5 minutes sitting there under the microscope with with this, which is a little syringe full of solder paste. But hopefully the live stream will work from the... Oh, Sion says you can make your own stencils. Yes, I can. And that's what I'll do. So once I get beyond just doing like one of these, I just want to check that the design works. So what I'm going to do is switch over to this view, and I'm going to take the microphone and drag it across as far as I can towards the microscope, and you should be able to see side view from the camera and the microscope. I'll just get this soldering iron out of the way. Now, this is... I don't know what I'm going to do while I'm doing this. I need to tell you a story or something. Can't think of any stories right now though. So, what should I do? Problem is that the focus on the camera is not quite the same as the focus through the eyepiece. And working through the eyepieces is much, much better because you get proper stereo view. So one of the things that you'll see if you're looking at microscopes, maybe that's something I should talk about. Okay, so if you're looking at microscopes for doing this sort of thing, you've got a couple of options. The cheap option are the simple USB microscopes. They've got a camera on a tripod, and on a tripod like on a little boom stand, and a screen on them. Typically they will have a screen, it'll be like a 9-inch or 5-inch or whatever screen physically attached, and they usually have USB on them as well, so you can connect it to a computer and basically use it like a webcam. And then when you are working under it, you don't have any direct optical path to what you're working on. What you're looking at is purely the view from the camera. Oh, didn't put quite enough on there. And so there are a couple of issues. One is that in those systems, the camera is a single camera. So you have mono vision, not stereo vision. And the result is that you have no depth perception. Now, what you're looking at now on this live stream is the view from the camera. Oops. Is the view from the camera that is looking down in parallel to the two eyepieces. So this is what's called a trinocular microscope. It has 3 sets of optics internally. There is one dedicated path with lenses for the camera, and then there are 2 dedicated paths for the 2 eyepieces. And if you look up from underneath the microscope, you can see that there are actually 3 lenses under there, and they can be independently focused to some degree. So what happens is that when you're looking through the eyepieces, you get full stereo vision with depth perception, which is incredible. It makes such a difference compared to just looking at either a mono view under a microscope or looking at it on a screen. So you're seeing a very flat view here. So if I move this nozzle up and down, you can see the focus changes, but you can't really tell how high it is above the pad. But looking through the eyepieces, I've got perfect depth perception. So it makes it a whole lot easier. The other issue with the camera-based microscopes is that there is often a bit of lag in the camera, because what's happening is that the camera is processing the image and passing it through to the little computer, which is then driving the screen. And the delay may not be much. It might be, in the order of 100 milliseconds, maybe a couple of 100 milliseconds. But that is enough that it gives you a really weird feeling when you're working under it. You move something, or you move your tool, whatever you're working with, and there is a very slight delay on what you see. So the result is that it takes a bit of getting used to. It's almost like a motion sickness effect. And it varies depending on the type of microscope. Some microscopes have almost no lag. Some of them have really bad lag. And yeah, so it's important to get one that doesn't have lag if you're working through the camera. So with what I'm doing right now, I could be sitting here, like you can see me from the side view. Up here I've got a screen on my bench which is connected to the HDMI output. What I've got here is the camera from the microscope goes into a game capture system which has USB to my computer, which is how I'm streaming this. But it also passes HDMI out to the monitor, which is up above my desk, so I can see on the monitor what the microscope is saying. So I could be doing this, sitting back here, looking up at the monitor. So what I'm seeing now, looking at this monitor, is exactly the same as what you are seeing through the live stream. But this is really clumsy. This system has very little lag. The latency is actually really good, but the lack of depth perception is really off-putting. I mean, I've got into a bit of a flow now, but I'm kind of feeling my way through it. I'm not using my eyes to do it the way I should. So working directly under the microscope like this, where I can see what I'm doing, is so much easier. So USB microscopes or camera microscopes tend to be cheaper, a lot cheaper, and for only occasional use, it's definitely worth getting one. If it's the choice between no microscope and a camera-only microscope, go for the camera microscope, because once you can see in detail what's going on, it changes everything. It makes such a difference. It's like having a superpower. Being able to look at parts like this and see in detail down on the board what's going on, it's fantastic. One of the things that I really like to do is solder under the microscope, because there's this weird thing where if you touch a solder joint with an iron and you're just looking at it with your naked eye, it basically looks like the joint all melts at once. But if you're looking at it under the microscope, you can see the heat front travel through the solder, and you can see it like you can see which part of the solder is still solid and which is molten. It's kind of weird actually, but very cool. Alright, so back to this microscope, and I'm still filling in time babbling incoherently here while I just do this mindless job of putting paste on the board. So that is camera microscopes versus optical microscopes. If you can get an optical microscope, it is preferable. Definitely stereo. Now, one thing to keep in mind, this is something that that traps a lot of people, is there is a big difference between a stereo, how do I describe this? Okay, a trinocular microscope. Trinocular is binocular plus the third port for the camera. And what a lot of microscopes do is they say they are a trinocular microscope, But what they do is they use a little mirror internally so that the camera path from the light path from the camera goes down through the left eyepiece's lens, and you can't use the left eyepiece at the same time as the camera. And there's a little thing on the side that you can switch between camera or eyepiece. So while you've got the camera running, you only have one eye, which is really annoying. So the trick for that is, if you're looking for a microscope, get one where in the ad it says simulfocal, and that means it'll simultaneously focus both eyepieces plus the camera, and then you'll be fine. Oh, I missed a couple of spots here. Got to put down that one, and that one. Did I miss any others? I don't know. There's lots more I could say about microscopes, but let's... Did I miss it? Any? No, I think I've got it all. Okay, now that I've pasted that up, I'm going to have a quick look at the chat and see if you've been able to hear what I've been randomly talking about. Oh, Legion X said, "Hey John, why is the lapel mic not wireless?" I'll clip this back on to this. Where are we? Feel like we're icing a cake. Yeah, I have a wireless microphone which I use with my normal camera, and I tried to connect it this morning, but I didn't have the right connection to put the receiver into the computer. I'll try and get that fixed for a future thing so I can walk around with the microscope. Oh, with the microphone. Okay. Station 240 said, "What solder paste is that? Mine never flowed that well." Good question. Which one is this? CT. Oh, it's ChemTools. This is it's from ChemTools Australia, and I don't know which particular type it is. This one is a leaded paste. It's not unleaded. That might make a bit of a difference. And up until right before the live stream, this was sitting in the fridge. I've got a little bar fridge in the bathroom through there, through that door, and that's where I keep solder paste, and I've got tubs and stuff in there as well for when I use stencils. Okay. Mr. Fixit said, "I was soldering last night with my old Weller soldering gun and it caught fire. I was running through the house with a flaming soldering gun heading for the back door." That's not so good. Okay, so in terms of which microscope, I mean, I've got so much more I could say about microscopes, but maybe we'll come back to that. Let's get the machine running. But before I do that, I'm going to put in a link. So that link has, that page that I just put in has links to things including the specific microscope that I have, and there is a link to the version that you can buy with the camera, and the same thing without the camera, so you can decide whether you want it or not. And it's on the more expensive side out of all the options, because I've gone for the swing arm. Hang on, you can't even see it. I'll go back to the side view. Okay, so this is mounted on an arm that lets me swing it around anywhere I want to. And getting it like that is really useful. You can also get them on just a fixed base, so you have to move the object around under it. And you can also get it on a version that's got like 2 bars, and the whole thing can slide in and out. But the really nice thing about this is that you can move it anywhere in space. You can basically move it up, down, left or right, and just let go, and it stays exactly where you put it. And it's one of those things where if you can spend $100 on a microscope, you can spend $1,000 on a microscope, or outside of those ranges. And for the amount of time that I end up using it, I figure that it's worth getting something that was basically as good as I could afford. And I haven't regretted that at all. All right. So let's switch around to the other camera and have a look at this pick and place machine. Let's see. Okay, so we're now on the Android phone. Oh, Aaron asked, does the camera come with it? You can get it either with or without the camera. I got mine from a seller called Fiscope, and you've probably heard, if you've watched Lewis Rosman's videos, he's always talking about Amscope, which is a pretty well-known microscope brand. So from what I can tell, Amscope is an American-based front for a Chinese microscope supplier. And it's weird talking and looking at the back of my head. And the actual place that they source their parts is from some of the same factories as Fiscope. So Fiscope is buying directly from China. Amscope is buying through the US distributor. Now they do some things slightly differently, like they bundle some different things with it. They've got different camera options, but I got mine from Fiscope. And what they have is an incredible range of dozens of different heads, different camera types, different eyepieces, different lens systems, Barlow lenses, different mounts. So what you can do is buy every piece individually and construct your own custom microscope, or you can just go for one of their bundles that has all the things you need, and they've got many different bundles. So the page that I put up there earlier has links to 2 bundles. One of the bundles is the same as the one I got, and the other one is the bundle minus the camera. So hopefully tattoo time. Maybe he's got. Alright, so I'm going to put this put this microphone down here on the bench, grab the other camera, and let's see if I can find a position that's going to make sense for being able to see what's going on here. Alright, so before I run it, what I'm going to do is, I hope you can all still hear me okay. I'll speak up. Alright, before I run it, I'm just going to show the major parts of it, and that way you'll know what I'm talking about in a moment, and then we can come back and talk about details later. This is the head, which moves in X and Y, pretty much like a 3D printer. And then these nozzles move in the Z axis, so they move up and down, and they can also rotate. And this is a camera, so this is a vacuum pickup nozzle. That's the downward looking camera. We've got vacuum hoses coming through here. There's a stepper motor here with a hollow shaft, so the vacuum can go through it. I've got fixed place feeders here, just cut tapes. There's a spot here where the target board goes. In fact, I'll put that on now. This is the PCB that I just put all the solder paste onto. And I've got these little magnetic board mounts. So once I've got it set up for a particular board, I can just drop the board in and it sits in place. These are just little 3D printed mounts with magnets glued in the bottom, so I can snap them in place wherever I want. This is all steel, this base plate. These are the auto feeders. We'll probably look at these in detail in a little bit. Reels of parts down here. Down this side, there's the motion controller. There's a tiny G motion controller down there. There are also a couple of aquarium pumps, like fish tank pumps. And one of those is providing vacuum and the other one is providing positive pressure. Down there are 4 vacuum solenoids which are used to provide either positive or negative pressure to the pickup heads. What else? Bring this around the other side. Now down underneath it, that is a PC motherboard. It's running Ubuntu. That's an i7, which is kind of overkill for this, but I had it spare, so I used it. There's an Arduino down here connected by USB, and that is running a G-code interpreter. And there's another Arduino down here. Can we see this? Yeah, so this is the one that controls the auto feeders. That's also running a G-code interpreter. So the OpenPNP software, which is running on this Ubuntu machine, talks G-code to the 3 controllers: the motion controller for the main machine, the head controller, which controls the vacuum solenoids and the servos, and the one down here, which controls the auto feeders. Sorry, I just need to wipe my nose. Alright, so is everybody hearing me okay? Oh, Legion X, he made me look. Said there's a lawnmower stuck in the hole. In fact, if I bring this over here, you can see way off in the distance, just there, that's the auto mower sitting in its docking station. And the hole that it keeps getting stuck in is right about there. You can't see it though because of the angle. There's a bit of a patch of dirt right there. And that's where my dog keeps going to dig a hole over and over and over again. Alright, so I'm going to try to get an angle here where I can get up to the machine and you can still see what I'm doing. It's going to be quite awkward. Alright, so I can drive the machine from OpenPNP. Oh, I might have enough length here. I can put the microphone back on. Alright, so hopefully you can see this screen. You won't see the detail, but you can get the general idea. This camera here is the view through the downward looking camera. There's also an upward looking camera. So if I go to the bottom camera, that's now looking straight up at the ceiling, and you can see the lights there on the ceiling. So I'll go back to the top camera, and there's a graticule on it that shows the position and the rotation of the head. Now I can go to the jog controls, I'll home the machine, and what I've done is put little optical limit sensors on the X and Y axes, so it's just done the X axis homing, and now it'll do the Y axis homing. It's coming up to find the sensor. So at the moment the position on this is all open loop. It doesn't have real-time feedback on its position, so much like a pick and place, much like a 3D printer, it relies on homing and then it does everything relative to the home. So now I can use the jog controls and I can move the head around to wherever I want to, somewhere in the order of a few hundredths of a millimeter accuracy. And unfortunately you won't be able to see the detail on the software here, but if I come into Open Recent Job and I'll pull up the job for this particular board, it's got a list of all of the parts that need to be placed, which feeders need them, and I need to clear the placements. Where is this? Job. reset all placed. Okay, and this is the point where I've got to go through a bit of a mental checklist and figure out what is set up. First I need to activate the auto feeders, so I'll turn those on and they are now live. I also need to have vacuum, and this is where it's going to get a bit noisy. So the two vacuum pumps are now running, and I'm always hesitant at this point because things can go badly wrong. I've got to make sure I've got, oh yeah, okay, so first thing is we'll check the position on the board. So if I go to the position of the board, that's the bottom left origin, and then it's got some fiducials on it, so I can pick a fiducial and then move to it, and the board is not quite right. At the moment, after doing the major rebuild on the machine, I don't have the OpenCV pipeline working properly, and you'll see what's going on with that in a minute. So I've just moved the board to make it align with where the camera is expecting it to be. Okay, and then if I go back to the first fiducial, that should still be on. Yep, close enough. So I think it's just about time to hit go. Now, any other comments? No. All right. I'm amazed at how nervous I feel about this, having it run live. Let's see if the head crashes into the feeder or the feeder doesn't work or whatever. Alright, so this job is going to take quite a long time to run. It's probably going to be about 11 minutes. So while it's running, I will, assuming it doesn't freak out, I'll move the camera around and point out some other things. So, time to hit go. Oh, no, it's crashing. I told you it would be a disaster. That's what the machine was doing just before I went live on the live stream, and I thought it had stopped doing it. So, hang on, I'm going to, first thing is turn the actuators off for the auto feed. I'm going to rehome the machine because it just crashed. It's lost its position. And I'm going to do a little test while it's clear of all objects. So I'm going to, I'll jog it down here. And what I'm going to do now is run a discard function. And what this should do is move the nozzle over that little tray at the back and then lower the head. If it screws up, it'll lower the head while it's moving. So let's see what happens. No, see, that worked fine. So the discard worked, but then when I ran the job it didn't. So I'm going to move the head over here. I'll do the discard job again. Yeah, so you can see there, that's the sequence of what it should be doing. So I've got to put this microphone down so I can move closer to the machine. And let's see if we can make it crash again. I told you this would be a disaster. So I suppose that's one thing about having these holders just stuck on with magnets. It doesn't really do too much damage. If everything goes wrong, it just knocks stuff out of the way, and then you can stick it back again. So, as a bit of background to explain why I have this specific problem, it's largely because of the motion controller for the chassis, and it's been driving me bonkers. It's a tiny G motion controller, and wonder if we're ready to try again. Dodgy asked, is this older pay still okay? Yes, it is. This is, I think it's a thermally stable solder paste, which means that you can leave it exposed for a little while. I mean, you wouldn't leave it out for days, but I've pasted up a board and then taken a couple of hours to get around to placing the parts, and it still works just fine. Alright, so let's have another go at this, and I'm going to start by just to avoid any possible damage to the feeder, what I'm going to do is move it to the position of the first feeder that it's going to need, which is the 1K. So what will happen is that because it's already in position, it doesn't matter if it starts to lower while it's moving because it's already there. And then if it crashes, it'll be crashing into the board and not into the feeder. And the board is more movable than the feeder, that's for sure. So, one thing I forgot to do is I didn't check the position of the board. Let's have a look. I'll go down to first fiducial. I just stuck it approximately in place. I've got to go through this process now of moving it because OpenCV is not working properly. Okay, first fiducial aligned. Second fiducial is close. Oh no, I should probably explain what a fiducial is. It's a positioning marker on the board. What happens is that the machine needs to know the exact position of the PCB, and because the mechanical routing around or cutting around the edge of the PCB is not necessarily very accurate, the position of the parts on the board can't be trusted relative to the edge of the PCB. So you can't just make a bracket that holds the PCB in the correct place based on its edges. So what you have to do is use features on the PCB to figure out where things are. And a fiducial marker is like a little pad on the board that is used purely for optical alignment. And they can take different forms, but in this case they're just little circles. So what I'll do now is move the feeder back to the 1K. I'll move the head back to the 1K feeder and do the mental checklist again. So I need to activate the feeders, and let's see what happens. This is where it could all go wrong again. There's no particular reason it's going to work now when it didn't work before, but if this fails, oh well. I'll mess around with it off camera. I'll just talk to you instead. So let's go. Play. Let's pick up. Oh, that's better. See, it's moving now before it lowers the head. So now that it's underway, it shouldn't screw up, and I'll see if I can move the camera a little bit closer and still have it focus okay. Once again, I've got to put the microphone down. Alright, so back to that motion controller problem. What is happening is that the TinyG motion controller doesn't necessarily report its position as it's going. What happens is that OpenPNP relies on the motion controller telling it when it's done. So it sends a command like go to these coordinates, and then it watches the values coming back from the motion controller that say what its current coordinates are, and then when it has reached its destination. And the problem is that the TinyG doesn't report consistently, and sometimes what happens is that it immediately returns, so it will accept a G-code and begin moving to a certain position and just immediately say, yes, I've got it, I'm done, even though it hasn't actually finished moving yet. And then OpenPNP thinks, hey, we've already arrived, I'm at the place I need to pick up the part or put it down, and so it then sends the command to lower the head. But we haven't got there yet, so the head ends up being lowered while the whole gantry is in motion, and it crashes into things. I've got a smoothie board somewhere as well, and I've been thinking about maybe switching over to using that, but I don't think the smoothie has enough stepper drivers. I'm not sure. I can't remember. It's a while since I was looking at that. So this process is going to take, as I said, about 11 minutes to run through the about 112 placements that it needs to do. Now there are a few ways that this can be optimized. One is that the auto feeders can advance before they are required. What you can see here in the sequence is that the nozzle puts down a part and then it pauses because the controller is telling the auto feeder to advance and bring the next part up ready for pickup. It then moves the head to the feeder and picks it up, but it's wasted time because it hasn't been moving while the feeder was bringing its part up. It's a tiny change in the OpenPNP config to tell it to pre-advance the feeder so that there is always a part ready, and then the gantry just about never stops. That overall makes it maybe 10 or 15% faster. At the moment it's running at a rate of about 600 components per hour, and you can also see at the moment that this is in what's called an open loop system, so it's not using the vision at all right now. What it can do is use the down camera to find the pickup position of the feeder, and it can also use the up camera to correct for any imperfections in the alignment of the part when it's on the nozzle. Because the parts can move in the tape, when the nozzle picks it up, it might be a little bit skewed or off to one side, and by going over the camera, it can use OpenCV to process it and then apply corrections. Right now with these particular parts it's not doing it, it's just running open loop, where it's not looking at what's going on, it just sends a sequence of commands. In a little while it's going to get to placing capacitors, and then it's going to go into a closed loop system, and you will see that it will use the camera to firstly locate the part using the down camera, and then it will carry the part over the bottom camera. The bottom camera is the little round hole that you can see directly between the two banks of feeders. Under there is a webcam that's looking straight up, and it's had its lens modified so that it's like a macro and it can focus very close. It'll move the parts over that hole and be stationary for a moment while it takes a photo and then uses OpenCV to process that image and then apply corrections. Now that's something else that is being weird at the moment on this machine. Since the major rebuild a little while ago, the corrections that are being applied by OpenCV I think are backwards. So if the part is skewed in one direction, instead of correcting the skew, it makes the skew twice as bad. And I think that's just because of there's some configuration I've got to do in the OpenCV pipeline. And so maybe once this job is finished, I'll explain a few of the changes I made to this machine fairly recently, which was part of the big rebuild that I did, which is also partly what's led me to having all these teething problems. The machine was working reasonably well before, and then after I totally pulled it to pieces and rebuilt it in a different way, I've now got these sorts of configuration and teething problems. And also I switched from the OpenPNP 1 codebase to OpenPNP 2 and had to recreate the whole config from scratch, which means I've reintroduced problems that I'd already ironed out in the previous setup. See the screen more? Sure. Hang on, I'll move this. There. So now you can see the view of OpenPNP, and you can see the camera view that's coming up, and it's working down the list of parts and marking them off. There is a little checkbox there's a little checkbox next to each of the parts that says whether they are placed or not. And if you look very carefully, just down here, you may not be able to see it on this screen, this checkbox, that one just got populated. So that one is now done, and now it'll populate this one. Yeah, so it's going down the list. Some of these parts are set to do not place, and it's only doing the ones that are configured at the moment. So it's getting down towards the end of the 1K resistors. So it's done, it'll have done 101 of the 1K resistors, and then it has a few other things to do. So fairly soon it should move on to the capacitors, which is where things can go wrong as well, because it's using the OpenCV system for checking the position of the capacitors. And I have lighting issues as well at the moment. Right now, as you can see, I'm running this in full daylight, and that is very far from ideal. Now it's just gone over, and you can see there's a delay. That's because it was using the camera to find the part, and then it took it over the up camera. You can see it's finding the part, moves to the pickup position, grabs it, brings it to the up camera, and then puts it down on the board. Now, one of the limitations I have right now is that I've only got one working nozzle on the machine as well, and I don't have a nozzle changer set up. So I can't change sizes of nozzle during a job unless I stop the machine and manually change it. And it's about to try picking up a large diode, and it may not be able to do it using this nozzle. Let's see what happens. Oh, it's done it. Cool. So I picked up the diode, and it's parked itself. So the job is now done. Yeah. Capacitors are wonky as hell. Yes, that's what I was talking about, Scott, with the OpenCV correction. It'll be sticking them in at totally the wrong orientation. So now we get to put all of this under the microscope and see what happened. Right, I'm going to move up closer to the machine. You can hear the feeders chattering away to themselves. There were only 2 auto feeders used on this job, just 1K resistors and 4K 7s, and some fixed position parts. So now I'm going to turn off all the stuff that's making noise. So I'll turn off the air and I'll disable the feeders. Where are we? Actuators, auto feeders, disable, so they'll shut up, and I'm actually just going to turn the machine off now, so I'll exit out of, no. So disconnect from the machine. So OpenPNP should now be disconnected from the motion controller. Turn off power, and take the board, stick it under the microscope. Let's see what damage we've done. Alrighty, back to microscope view. Hang on, before I get into that, let's have a quick look at the chat, see if there's anything else. Oh yeah, there were some comments about the lag on the video. Yeah, that is lag from the IP camera. I'm seeing it locally as well. It's not just YouTube. What happens is the camera is streaming, acting as an IP camera over Wi-Fi, and then I'm using that as a feed into OBS, and then OBS is merging it with everything else and sending it upstream. But I also see the lag. It's a local problem. Scott said at least didn't flip the board over. Yeah, that wouldn't have been fun. And Ecognito3 said, I got blamed for minor damage to 2 robots in the lab in uni. The first was my fault, negative offset instead of positive, tried to dive the robot arm into the tabletop. Yeah, that's not fun. Alright, so let's see. What else have I missed? Okay, this is a good question. Dodgy asked, how come we don't see the part being placed? And this was talking about the view when I had the camera looking at the screen for OpenPNP. The reason for that is the camera is not aligned with the head. So what happens is there are two different, there's an offset. Let's switch this back to here. So there are lots of offsets involved in this machine, or in any pick and place machine. It's using like a Cartesian coordinate system with 0 as the bottom left in this case, and then everything else is relative to that. And there are some things that are fixed positions like feeders and the position of the board, and there are other things that are moving positions like the position of the nozzle and the camera. So the camera and the nozzle are side by side with a known offset relative to each other. And then when it's doing a job where, for example, it picks up a part from the board, or if you are looking at the board through the camera, and in OpenPNP you can have it exactly positioned over a component, and you then want to move the nozzle to that location, it moves the head, so you then lose your camera view. So you can either have the camera view or the nozzle in the correct position. You can't have both at the same time. So while the job is running, what you are seeing through the camera is basically the offset, and it's just going to be showing you a random bit of the board beside whatever it is that you are doing. Okay, so, and Aaron said, my OCD is kicking in with resistor labels being different way around. Yeah, let's see how that goes. Now, it'll be interesting because I've never actually looked in the tape to see if they're all the same way around. Yeah, I think they are all the same way around in the tape, but yeah, okay. Time for a visual inspection, and we're going to see how badly those capacitors were aligned. Alright, now there are a couple of interesting observations here. First is that you can see that this first resistor that we're looking at seems like it's way out of place, and in fact it is offset a bit. You can see that these are consistently offset down from the pads. That's excuse me, that's probably because I didn't have the board in the exact correct position. And I kind of get a bit lazy about that because you don't need to be as precise as you think you do for a lot of this stuff. And you'll see in a moment when we reflow this what goes on. So I probably just had the board offset. Now you can also see that there is some variation between them in the position. So this one is slightly left and then a little bit left, and then, you know, they're not all perfectly offset by the same amount, which is what you would expect. Now that is, up here you can see quite a big difference. If you look at the difference between these two parts, which should both be aligned to their pads, that will be because of the parts moving in the tape. And the tape, in fact, I'll grab a bit of tape and show you what it looks like. There's some tape with a part in it. I'll cut off some tape. Alright, so this is a bit of paper tape with 100 nanofarad capacitors in it. And what you can see is, in fact, if I reduce the lighting on this, we should get less glare, and then you'll see more detail. You can see that there is this, which is cardboard or paper, just called a paper tape, and then there is a clear plastic cover over it which holds the parts in place. And if I turn the tape over so it's on the other side, you can see that there is a similar sort of thing on the back. This is it's like a gauzy tape that covers the back of it. So on the top of the tape you can see the holes that have the parts in them. You can also see that those parts are smaller than the hole and they can move around. So if I do that, you can see that they can flop down to one side, they can rotate, and they can offset by a significant amount within the tape. Like it can move that way or move that way, and it can be rotated. Let's try that. You can see this one here is rotated and it's offset. So even if you have the pickup location perfectly centered and the nozzle comes down and grabs the part right there, it will end up offset. And it can be different from one part to the next depending on how the feeder vibrated as it was advancing the tape. And that is really why the vision system is useful with the bottom camera, because what it can do is look at it, the view of the part once it's been picked up, and then see if it's not where it expects it to be and apply a correction. But for all of these 1K resistors, we were running in open loop with no vision correction, and that's why you see that variation. Now I'll turn this brightness back up so we can see it. And you can see the parts just sitting in the solder. Now, oh, yeah, you can see here, this one is way off. This is rotated, it was rotated almost 90 degrees. So I'll just shove that back into place. And this is what I was talking about with the vision correction is currently going in the wrong direction. So instead of vision correction, it's vision make it worse. Now with these parts, I actually don't care about that alignment. This is fine. What we will see is that when this reflows, this solder paste, in fact I'm going to zoom in on the solder paste just in case you haven't seen it before, because it's kind of cool. Let's move way in and see if we can see detail in the paste. See if I can get some focus. In fact, in even more. It's kind of dim at that focus level. But what you can probably see is that the solder paste has all these little dots in it. Where's my pointer? I'm at a scale where the tip of the tweezers is like a tree trunk. So you can see all the little sparkles in it. Those sparkles are balls of solder. So the solder paste is a suspension, which is the carrier, and balls of regular solid solder inside it. And it comes out kind of like a toothpaste consistency. And you squirt it out or squeegee it out onto the board. And that aqueous carrier allows it to, I don't know if it's aqueous, sometimes it is. And that carrier fluid allows it to sit in position, and the balls, which are like, it's basically like dust, it's like solder dust, are then kept within it by the surface tension of that liquid. And when it reflows, the carrier boils away, the solder melts, and it makes a solder joint. So I'm going to zoom this way back out so we can see what's going on. So what happens, and this is why I was saying earlier that I don't care about that orientation so much. If we look at these parts, what you can see is the part is sitting and touching the two blobs of solder paste. When this reflows and the carrier starts to boil off, it becomes very liquid, and the surface tension will pull the part into alignment. Because this is close enough, there's no need to correct that, that's fine. That'll end up perfectly aligned once it's actually soldered onto the board. So what we're looking for here are a couple of things. We're looking for parts that are so far out of position that they are not touching the solder on one end. Like this one is kind of borderline, that'll probably flow okay anyway. But if it's only touching on one end, then it can end up tombstoning. And parts like this, where the machine has totally screwed up and just put it down in the wrong place. And what's going on here? Oh yeah, so this is the same thing. So these two resistors, which is the 4K7 resistors, these are I2C pull-ups, these ones had, I shot off the resistor. These ones had vision turned on the feeder. I'm getting deep in my tweezers now, and that's why it's totally screwed it up. So at the moment the machine actually runs better with vision turned off. Right, so check those are aligned close enough. This one could be a problem, so I'll just adjust it. Make sure everything else is on. Yeah, there's the diode that it put on. It managed to pick that up okay, even with the small nozzle. Should have been using a bigger nozzle for that. Oh, there's the first part. That's because the machine crashed. You can see that there is one missing there. And what is that yellow stuff? That's probably a result of it crashing as well. So what I'll do is chuck a 1K resistor on there. So when it crashed, I didn't reset the counter that that showed which parts had been put down. So then when I ran the job again, it thought it was already there. Oh, you can see the markings are different. It's all upside down, but this one says 01B and this one says 102. These are all 1K resistors. They're just different, from a different accuracy. I think this might be like a 5% resistor, and this is a 1% resistor. Different marking scheme. Anything else that looks obviously wrong? Nothing that's going to be a big problem. I'm going to chuck a couple of capacitors on it. Now I don't actually have the correct capacitors for this, and they're just like bulk smoothing caps anyway. I'm going to put on some that are dramatically too small, but it will still work. And chuck one on there. What I really need is someone sitting in the room with me, watching the chat, and telling me about any questions or anything that are coming up, because I can't do this and watch the chat at the same time. Those are on. What else do I need to do? I've got to put on some chips. Now, because I was stupid and didn't think ahead, I didn't have enough of these MCP 23017s, and right before the live stream I actually floated these off another board. So I just used the hot air and removed them, and now I'll put them onto this board. They're a little bit sticky from the flux, so I put tack flux on on the pins while I was removing them from the other board, just to make it all flow a bit better. Maybe what I need is a screen with the YouTube chat that's visible up here somewhere as well. Or I could put it on a tablet maybe, so I could carry it around and have it with me wherever I am in the room. What is that? Get off. There is some strand of something attached to the, it was stuck in the flux on the chip. Last one. Get off. Alright, so we now have the board ready to put in the oven. So, time to switch cameras, and let's have a look at the reflow oven. So this is my my reflow oven. It's a T962C, I think it is. I can't remember. I built this enclosure over it to reduce the amount of fumes that come out of it. It's kind of large as domestic, like as small reflow ovens go. The large ones that are used in factories are more like a pizza oven with a conveyor belt through them. This one with the drawer is a manual oven that you just use for small runs and things. So turn that on. Put that inside. Now I've just sat it on a couple of spare PCBs to, I don't know, don't even know why I did that. I think actually it's because the bottom of this tends to buckle a little bit as the temperature changes, and this just helps it sit up above it. So there are a number of different reflow profiles. See if we can get a view on here. The menu system on this is horrible, and so we're going to F3 to select a profile. This is time across the x-axis and temperature across the y-axis, and that's the profile that it will follow. I want wave 2, so I'll select that. And for some reason, every time you exit out of this, it goes back into Chinese menu mode. So then I'll switch it back to English menu and hit start. So now, come on, start. So now it's running this wave, and the temperature will, this is the target, what you see here on the chart, and then it's going to try to follow it. It won't get it spot on, but you'll see the actual temperature on there as well. Now I'm going to move this back a bit and see if I can improve that microphone situation. And I'm back at the computer. So while the camera is sitting there pointing at an oven, which is not the most exciting thing, I'm going to go and cut off, no, I'm going to go back and catch up on chat. Aaron, way back in the chat, Aaron asked, is this full speed? So that's in relation to the speed the machine was running at. Well, it's kind of full speed for now. There are a few things I could do to improve it. I can change the way the feeders preload their parts. I deliberately don't do that at the moment because when the job is done, you then end up with all your feeders with one part exposed. And if you're doing a whole lot of boards, then that's fine, but I just do odds and ends here and there, so I prefer to take the slight speed penalty and have the feeders only advance the parts when they're required. And I can also do things like speed up the motion of the gantry. This gantry is fairly heavy. It's actually designed for making a CNC machine, so it's way more mass on the moving head than is necessary for a pick and place machine. You'll see that pick and place machines designed for speed try to minimize the mass on the moving head. And this one is large, so it's got the steppers are running moderately high current, and it's working quite hard to move the head around that quickly. Oh yeah, Sion said, why are you not using resistor arrays? Potentially 4 times less pickup and placements. Yeah, that's true. That would be a good idea. I just don't happen to have any resistor arrays. And I had lots of 1K resistors, so that's what I put on. I also am kind of lazy about things like small pitch pads, and K16 arrays are pretty easy to place as surface mount parts go. They're not too small, but when I'm using a syringe for things, it's a bit of a pain. Now, what else? Reflow is rather forgiving, yes. Here's a really good question. Peter Kirkhoff said, I noticed the board flexes a lot when the nozzle hits it. Is it too far down? That is an excellent observation. Now, that is one of the little quirks about my pick and place machine. And with most pick and place machines, what you find is that they have a fairly well-tuned Z axis. And when I was first building this machine, which was 7 years ago or something, I didn't want to have to calibrate the Z-axis, and so I kind of cheated. I'm going to move the camera back around and explain a little bit more about the machine. In fact, I'm going to close the blinds because that's going to help the lighting and you'll be able to see a lot better what's going on. Alright, hopefully that will reduce glare and you'll be able to see this area a little bit better. What we've got, excuse me, feeling quite croaky today. Instead of driving the Z-axis directly, this is just sitting on a little track. And you can see that it's being lifted up. There's a bit of string. This is so crude. Up here is a servo. So this is just a regular hobby servo. And it's a bit of string that goes down to the carriage. And the carriage moves on this rail. So the servo can lift it or lower it. And what pulls it, excuse me, what pulls it down is just gravity. There is nothing physically pushing the Z-axis down. So it just gets lifted by the servo and then lowered down. So when it wants to do a placement, the servo moves down and this is lowered, and you can see that the nozzle is also spring-loaded. I can push it up. That is to allow for tolerance on machines that directly drive the Z-axis, so that if you try to drive it too far by a millimetre or so, the spring compresses and you won't destroy your machine or the board or the part that you're putting down. But what I'm doing is basically being lazy and just letting gravity push this down, and I've got it calibrated so that when it's lowered, it goes a bit lower than the position of whatever it needs to be. So the top of the PCB and the position of the pickup location here on the feeders is all about 13 millimeters above the deck. And so what I do is drive this so that it goes down to maybe 11 or 12 millimeters below the deck, or below that point. So, 11 or 12 millimeters above the deck, so 1 or 2 millimeters below the target, and then it relies on the weight of this to just push down on whatever part I'm pushing down. So that is it's kind of a nasty little hack, and it works surprisingly well. Now on most boards, so just as an example, here's another PCB. This is the more typical sort of size stuff that you would do. Flex isn't a problem. Like, you can't really bend that board easily. It's only because we're using that ridiculously large PCB that is not just large, but it's also really long, and that can flex. So what I should do ideally is have another support somewhere in the middle here, that when this board is in position in that area, you can make it flex. Like, it's not taking all that much force, and you can flex it very significantly. With most PCBs though, that doesn't happen. It's quite well supported. Okay, other things to point out while we're waiting for the reflow oven to run. Well, actually, just coming over here, you can see the little chart on the reflow oven, and you can see that the actual temperature is tracking fairly close to the target temperature. Now there is a certain point here where it can't cool down quickly enough. In fact, what I'm going to do, I'm going to temporarily mute my microphone so I don't set off all of your voice assistants.
Okay.
And I just used She Who Shall Not Be Named to turn on an exhaust fan. And the exhaust fan is connected to that blue hose. It goes down under the bench, runs around the room, and then vents outside. And that blue hose goes back to a T-piece, and it's picking up from both the laser cutter and from this fume hood. So what it's doing is sucking air through here around the reflow oven. It goes through and out the back, down through that T-piece, and then down through the blue hose and outside. But what happens is that as the reflow oven gets towards the end of its cycle, it can't quite cool down fast enough. So what you'll see here is that the actual temperature will start to deviate from the target temperature. You can see now that it's not cooling as quickly as it should be. So what I do to help prevent that is I just pull the drawer open a little bit. And that allows a little bit more airflow to go through it. And then the temperature can track more accurately. And also, any moment now that it's going to start beeping at us to say that it's done. It does a very loud squeal. Almost there. So it finishes, so I hit the stop button, there we go, and it just keeps doing that until I tell it to stop. And now it's finished its reflow, but it's still hot. Like if I pick that board up, I'm going to burn myself. So I just pull the drawer open. The board is sitting there fully reflowed, but I'm going to walk away and leave it for a few minutes before I go and try and pick it up. Sometimes when I'm feeling really impatient, I go over and I pick the board up using a pair of tweezers or bounce it around between my hands like a hot potato and get it onto the bench. But I'm going to be patient this time. Alright, so other things about this machine. The feeders are quite interesting. These feeders were designed by a guy in Germany called Michael. He's really only known by his handle of MGRL. And here you can see one with its cover off. And the tape comes in through the bottom here. And this is a little spring-loaded thing that stops the tape from bouncing. You can see the feeder here, there's a servo that pulls this back and then pushes it forward. And that little point, which is also spring-loaded down, hooks into the holes in the tape and it ratchets it forward. The tape then comes out through here and back out through the bottom. The cover gets pulled off. It comes up around here, up over this, which is spring-loaded down onto this micro switch, and then it goes down through this motor with a couple of gears on it. And the micro switch controls power to the motor. So what happens is that the tape advances, the tension goes off the cover, the switch comes up, the motor turns on, it then winds forward, pulls the tape tight again, which turns the switch off, and then the motor stops. So the tape remover automatically keeps taking up the slack. As the tape is advanced forward, the tape is peeled back. So if we look at the feeders on here, you can see the reel of parts coming up from underneath, goes through, and then it goes down through the hole in the plate, comes back out underneath, and the cover tape is peeled off it, comes back over here, down through the motor, and then it just gets left hanging under the machine here. So if we back up from the machine a little bit, you can see the tape for the 1K resistors, which is the parts that we've just been using. The discarded tape is just coming out the bottom here. And then periodically I've got to cut those off and chuck them in the bin. Alright, I'm going to kill audio for a second and use...
Okay.
Alright, the exhaust fan is off again, so hopefully it's back to being a reasonably quiet lab. And now, let's have a look at this microscope and see how badly we've screwed it up. Alrighty. So looking at this row of resistors, you can see that these are the ones that were offset. Well, they were all offset, but these were sitting down off the pads a fair way, down to one side. This one has pulled itself back into position. This one hasn't really quite. It's not aligned properly. It's a bit odd. But you can see here that most of them have pulled themselves into alignment with the pads, even though they were not properly aligned when they went into the oven. And the capacitor is pretty well aligned. Going down this row, you can see that these ones are pretty well aligned. We don't have any tombstones or anything yet. Everything seems to look okay. So what I'm looking for here are a couple of things. Firstly, I'm looking for the really obvious thing, which is parts not in their correct position. And that could be either offset in some way, like not making contact with one pad, or it can be tombstoned, which is where the, where's the pointer? There. Which is where one end has not made contact and the surface tension on the other end has pulled it, so the whole thing pops up and the resistor ends up standing up vertically. So that's called tombstoning. And another thing, obviously, is solder bridges. That's something else to look for. And there don't seem to be any problems here. All of these resistors are where they should be. The capacitors are aligned. Yeah, everything is where it should be. Now, the other thing to look for is on these ICs is bridging between the parts, or between the pads. Now, I'm going to try to adjust the brightness here. The view through the microscope camera is not quite as good as the eyepiece, so it's a bit hard to see. But you can see here that there is no bridge between. Oh, when I touch that, you can see the flux flaking away. You can see that there are no bridges here. Each of the pads is soldered separately. Now, because I had taken these ICs off another board just before the live stream, they still had bits of solder on the pads. They weren't perfectly clean like you would expect. So that makes it a little bit harder for them to be sitting down properly. Now, the other thing to look for on a part like this where there are multiple pins is if it hasn't been sitting perfectly flat, sometimes a part looking from above will look like it's connected, but it's actually floating above the pad a little bit. I haven't seen any evidence of that here, but that's something that's particularly a problem if you're reusing parts like I just have. And these undersized capacitors seem all right. Obviously there should be a much bigger capacitor, but this one still bridges across the pads, so that's fine. Overall, this is looking all right. So that I would rate as a successful reflow. There's more to do to assemble that board and make sure it's ready to go. Obviously, that's just the basic parts. All right, where are we? Let's switch back to here and have a look at the chat again. See if I can catch up. Alrighty. Oh yeah, so NN just reminded me of Scott Miller's comment about swapped the drive motor wires during the rebuild. Yeah, so what that's in relation to is the correction of the offset on the rotation when it picks up the part and then uses vision to figure out how it should be correcting it. That is a good theory, but it's not what's happening in this case, because what's happening is even when we're running in open loop, so we're not using OpenCV, so we're not using vision correction, it still has to rotate parts, and it's rotating the parts in the correct direction. So if I tell it to rotate 90 degrees clockwise and I watch the machine, it does rotate 90 degrees clockwise. So the mechanical control of the machine is okay. On the output side, that's fine. What I think is going on is that there is an algorithm, or there is an OpenCV pipeline, and what it does is take a photo of the part looking up through the board, and then it applies a mask. There is an image essentially which has like a blanked out area, so it removes parts of the background that it doesn't want to look at. It then does edge detection, so it finds, if for example you're putting down a resistor, it's going to be a rectangle. So it does edge detection and finds the boundaries of the rectangle, and then it compares that rectangle to what it's expecting to see, which could be a bit rotated, it could be a bit offset or whatever. It'll be not quite right. And then whatever the difference is, so if it was expecting the part to be like that, and it detects that it's like that, it figures out, oh, I need to turn it by 12 degrees anti-clockwise or whatever to do the correction. And then it applies that to rotate the head before it puts the part down. So that in theory, when the part is put down, that error will have been corrected. I think what's happening is that in the OpenCV pipeline, where it gets the offset and then sends it back into OpenPNP to do the correction, it's giving it the wrong orientation. Right now, the camera is looking up and the perspective of the machine is looking down, and I think that's the problem. So it'll be just in the way I've got the configuration set up. I need to fix the camera orientation or something for the bottom camera. So anyway, lots of stuff to play around with. Oh, Richard said, have you talked to your live stream setup? I'm assuming you have multiple camera streams going and you're toggling between them. I haven't actually talked about that. I've talked about it a little bit on the Discord, but not on the live stream itself. I'm using OBS as the software that brings all of the video streams in. At the moment, what you see back there is my mobile phone running an IP camera app, which is streaming the camera over Wi-Fi, and then OBS is pulling in that. It's pulling in my desktop. It's pulling in the a window from the game capture system. It's basically got a whole lot of sources coming into it, and then I've got a little menu and I can select between different views. So I can select if I want the front camera. I've got the side camera, switch to the desktop view, and at the moment I've got Fusion 360 running on there, so I can pull my desktop up live and move it around, and the microscope view, and the view from the Android phone. So OBS is really cool, it lets me do lots of stuff, but it's a bit of a pain having to manage OBS and switch between views and keep track of the chat and be trying to do stuff in the room at the same time. So I really need a producer sitting here with me to keep track of that sort of thing. Yeah, MKME Lab said, of course you have motorized blinds too. Yes, my whole house has motorized blinds all the way through it. And a few years ago, I did contracting work for a company that makes those blinds. And so I actually designed the controller that's in them. And those controllers ended up being installed in houses all over Victoria, some in New South Wales, I think. So Seabreeze said, what is happening in the laser with the side off? Oh, that's because I was replacing the controller. That laser has been rewired, so I've just added a Raspberry Pi running LaserWeb, and that, if you know about Octoprint for a 3D printer, where you can open a browser, connect to your 3D printer, you've got a view to be able to load jobs, and there's a live camera and all of that sort of thing. LaserWeb is kind of like that, but for a laser cutter. And I've got a Raspberry Pi sitting up on there at the moment running LaserWeb, and I've just been connecting it up to the controller so I can control the laser cutter over the network instead of having to go up and do it directly. On your windshield, Scott said, looks like a bird crapped on your windshield. Do you mean the window? Yeah, that needs cleaning. Oh, Wanaruna said, what is the tomato sauce used for? That is a bottle of water that I squeeze onto the sponges for the solder. Ah, that is a really good question. Dodgy said, why would it be called a reflow oven when it hasn't been flowed a first time? True, it should just be called a flow oven. And Govinda said, where did you post the link for the microscope? I'll just put this in. There is a gear page. I put this in earlier in the chat, but just to make it convenient, that page has links on it to the microscope and a few other things. And most of those links are affiliate links, so I get some fraction of a percentage of any value that comes on them comes from stuff bought through those links. So I just tell you that as a full disclosure thing. Oh, Darian said, saw a solder ball next to the ceramic cap. Yeah, that's actually something else to look out for. I'm going to switch back to the microscope and we will look for that solder ball. Thanks, Darian. Normally while I'm working on boards like this, I will also check for those and pop them off, but in this case I was kind of rushing through it. So we'll look ceramic cap, not that one, not that one, that one, yes. Okay, so what you can see right here, that spot there, that is a ball of solder, and the way that happens is if I put too much solder paste on the pad, as the part gets sucked down by surface tension, sometimes there isn't room on the in the joint between the pad and the actual contact on the part for all of the solder. And so what happens is some of the solder gets squeezed out and it forms a little ball which gets stuck in the flux. So at this point, while it's reflowing, the flux and the carrier will still be liquid and sort of boiling away there. So what happens is you end up with this little ball of solder that gets embedded attached to the side, and they're typically not electrically connected to whatever the joint was. They're usually just like glued there in the flux, and you can pop them off. So what I'll do is, in fact, I'll zoom in so you get a better view of this. Bring this right in, get some more focus. Turn up the brightness. There we go, that's a better view. So you can see there, this little ball of solder, which is on the side. Now, normally I would just flick this off with the, there it is, with the tweezers. And you can see that it really is like a ball. It's because surface tension has pulled it up into a ball shape. It's like a little solder ball bearing. And that was stuck in this flux that has solidified around the joint. So that's something else to look for. What I normally do is go around the board, and if I find any of those, I just pop them off with the tip of the tweezers. Is that another one there? Yep. So there's a tiny little one just there, and there's a tiny little one just there. It's quite deceptive, the scale that we're working at here. Like, it looks like these tweezers are quite large and blunt. These are very sharp tweezers. These are that's like a needle. You can stab yourself with this very easily. So things look like they're blunt, and there's one just there. See that? There's a little ball that popped out of the side. Now, generally they don't cause a problem. The worry is they can cause a short circuit or something, but the reality is that that doesn't really happen unless you've got way too much. And I'll just, once I pop them loose, just bang it like that to get them free. Unless you've got way too much solder on there and it ends up bridging, then you won't get a short circuit. It's just, I prefer to remove them, partly so that if later on something happens, like the board gets knocked or it's subjected to vibration and the little bits of solder come loose, you don't want them floating around in side, whatever the device is that it's been attached to. Now, if I was using a stencil, the quantity of solder would have been correct, and then that probably wouldn't have happened. That happened because I was putting it down manually with the syringe and being kind of slapdash about it. All right, so, there was a question here. I just lost it. There was a thing about automatic gain control on OBS. That is an excellent point. Hopefully that won't be a problem after this week. If I get an adapter, I can connect the radio microphone to it. And me walking around the lab like this is a bit of an unusual thing. It's because of obviously what we're showing. So most of the time the microphone will be right here with me and it won't be a big problem. All right. Mr. Ackland said tomato sauces for the hot dogs he cooks in the oven with the boards. Yeah, I could do lunch at the same time. So hot dogs with a side of lead and flux. Doesn't sound too appetizing. All right. Okay. So Espero Kali said, have you explored the possibilities of marketing your air quality measurement tool for consumers, users, or patients with lung issues? I'm going to be making more stuff available in relation to that. For the first few videos, the idea was to explain exactly what's needed if you want to go and build one yourself. But obviously there are many people that could benefit from it who either don't have the capability of making their own, like they're not able to solder, or they don't want to do the software side of it, or whatever. I mean, most people in the world aren't like us. They don't solder things together and load custom firmware onto it. So the what's going to end up being the 5th video in the series is going to be the pro version, or what I'm calling the pro version of the air quality sensor project, which uses a PMS 7003 sensor, which is the newest plant tower sensor. It's also got an ESP32 on it instead of an ESP8266. It's got a big display on the front, and it's much more of an integrated, ready-to-go unit. It's on a custom PCB. Just wondering if I have one here. I don't think I do. And what I'm going to do is sell those, and for people that are just wanting something that's ready to go, then that's an option. But of course there are many other places you can get them too. I'm not the only one doing air quality sensors. There are plenty of them around. Most of the reason for me wanting to do one is to be able to have more control over how it works, rather than just buying a device that's like an appliance and plugging it in and getting numbers out of it. I really wanted to understand how it worked and to be able to customize it to suit myself. So that will be, well, it's still going to be some weeks away before I get to part 5 of that series. Oh, it is too. Scott just said my car is visible on one of my screens. Yes, so I've got CCTV around the house and outside the house, and there's a screen up the top here which was showing actually my wife's car. Right now I don't have a car. My car was taken by the liquidator. My best friends, the liquidators. So, Sleepy105 said, I've noticed you use on-offs a lot. Doesn't the clicking sound of the relays bug you? I'm currently trying to make a board with a single pole double throw solid state relay to avoid that. Yeah, that's a good point. The clicking of the relays does annoy people. For me, most of the time, it doesn't really matter. I've got a, if you've seen inside my switchboard, I've done videos about that before. I've got heaps of relays in there, and you can't really hear that. If you're up in one of the two bedrooms that is adjacent to that wall, and it's really quiet, and you listen at the wall when a light is being turned on or off, you can just very faintly hear a relay clicking inside the switchboard, but you've really got to listen for it. That's not really a big problem. But following on from that, one of the advantages of using things like a solid state relay, or using using a triac, for example, is if you do zero crossing detection and things, you can apply dimming. So one of the big differences between a relay-based controller and something that uses a triac is typically that you can do dimming on a triac. But that's a whole other topic. So Benjamin said, did I miss where you said what board it is you are making? That's a good point. I didn't actually explain it. I kind of assumed it because it's a board that I've been talking about recently on Discord, and also on previous live streams I've shown it. But if you missed that, then you would not know. So just as a little aside, let's go to the desktop. This is ultimately the device that I'm working towards with this particular board. If I spin this around, you can see this long green board here. This is the one that we've just been reflowing. And what it's got is a whole lot of MCP 23017s, which are I2C I/O drivers connected to these RJ45 sockets. So the device overall looks a lot like an Ethernet switch, but it's not. Each of these connections goes out to a light switch in my house. Ethernet comes in here, and then there is a pass-through. There's a connection there if you can follow my cursor. So the idea is you use a little patch cable that you plug in there. The patch cable comes around and plugs into the Raspberry Pi. And down on here, there is a 6-way connector. And then there is an RDC cable, same as the ICSP cable that you would use on an Arduino. You plug one into there, and then the other one into this down here, and then one into here, and then one onto this hat on the Raspberry Pi. So this hat takes power over Ethernet and regulates it down to 5 volts, and also exposes it out on these connections. This board in the middle has a little keypad on it, and it's also got a display. So the idea is that these are menu buttons, and then there is a display on here. So the summary is that this is a rack mount light switch controller for home automation. And you plug it into Ethernet, you plug it into all your light switches, and either a Raspberry Pi or an Arduino can be located in here, and it can read when your light switches are pressed and then publish to MQTT or do whatever else it is that you like. If you use a Raspberry Pi in here, it means that you have the computing capacity to be able to do things like run Node-RED or OpenHAB or Home Assistant directly on this, which means the light switch controller becomes the main control device for your house if you don't have a system running somewhere else. Or if you do have a system running somewhere else, like you have an existing Raspberry Pi or a VM on a very nice server, which I know some people on the Discord have, then you have OpenHAB or whatever running in that, then what you can do is just put an Arduino in here. It doesn't need to be a Raspberry Pi, so that can cut the cost down a little bit. That's the end result. So that's the reason that this board is such a long, skinny shape. It's just because it's got all these connectors on it. You'll also see that we have used the pick and place machine to put on these resistors, and I manually placed these ICs because because I'd taken them off another board, so I didn't have them conveniently in a tape or anything to feed. But there are through-hole parts, like there are these big connectors that need to go on. There are these little RJ45 sockets here. There is a LED here. the model here isn't quite right for the LED. What I wanted was for the LED to come up and then the legs to be bent 90 degrees and then have it come through this hole in the case. So from the front, what you'll have is a power LED which is visible here. But the 3D model that I used on the PCB is just for a normal LED mounted down flush, and that's why it looks like that. That's not actually how it will be installed. And then I need to hand solder the power socket. So there'll be an option for either powering it using power over Ethernet, if your target device supports that, or just power it by plugging in a DC jack like there. Okay. Let's see, going back. Oh yeah, Scott said, while watching the paste application, I was impressed. Counting the solder balls, not so much. Yeah, I was not doing a very careful job. The way my brain works is I tend to be very focused on one thing. I don't multitask, and I don't even try to multitask. The way I put it is multitasking is a lie. It's just doing two things half as well. It's not doing two things as well as you normally would. So when I'm trying to do this and talk at the same time and explain what I'm doing, I'm kind of thinking about what I'm saying and not paying attention to what I'm doing, putting down the solder paste. So yeah, that was a bit of a rough job. Dodgy said, during this time of discontent with the virus that shall not be named, have you considered making some of the stuff we might normally buy? For example, I need a hand controller for my CNC I would rather buy locally. Yes. So that is an interesting question. My wife and I were just talking about this a couple of days ago. One of the excuse me, hang on a second. Because business has changed, well, my business has changed dramatically over the last few weeks. There is a question of if it's worth trying to provide some kind of a local assembly service, and maybe. So the big difficulty right now is lack of logistics, and I've got to admit this is not something that I predicted early on when this whole thing hit. My idea was, my observation was, okay, we can't go to local stores so much anymore. People are staying home, using online shopping. One of the very first things that failed here in Australia was online shopping. The week that we went into voluntary isolation, or whatever you want to call it, the major retailers here, the supermarkets, stopped their online delivery service. So you couldn't just pull up the Coles online website, order your groceries, and then have them delivered a day or two later, because so many people switched to using online services that they just couldn't keep up with it. And also they had issues with people not being able to pack the orders. And so they switched it so that their online shopping service was only available to certain people. I think you had to have something like a seniors card, or prove that you're in an at-risk group. So for a couple of weeks, we were told we're not supposed to go to the shops unless we absolutely have to. Oh, but by the way, online groceries, you can't do that either. And that was probably the first sign that things in the logistics world were really falling in a big heap. Where I'm getting to with this is the issue that I thought that what would happen is that we would be able to go into isolation in our houses, place orders for things, deliveries would still happen, but the reality is, if I want parts from China or wherever, getting stuff is really, really hard, and I can't ship out now. It seems like it should be the golden time or the golden age for online retailers. Now, during the week this week, both Sion, so Unexpected Maker, who is in the chat here, and myself made me made the painful decision to turn off international shipping for our online stores, and the problem is lack of flights. There just isn't enough cargo space because so many passenger flights now have been grounded. There isn't room to take packages. So both Sion and I have been told by Australia Post that there's a big list of countries now that we simply can't ship to. I've been told that I can't ship internationally using economy at all anymore. Like if I go to the post office with an economy parcel, they'll just say, no, sorry, we can't take it. I can ship using premium services like International Express Post, but that costs a whole lot more, and also they're really delayed. One of the notices I got from Australia Post, I think it was yesterday or the day before, no, it must have been Friday, was that they have suspended their guarantee on express post shipping. There used to be a guarantee that if you shipped something express post by a certain time of day, then it would arrive at its destination the next day. So they're no longer guaranteeing delivery times on express post. They are not shipping internationally by economy at all. Shipping by premium services international can have weeks of delay added to it. Something that would normally get overseas in 3 to 5 days using an express service might take a few weeks to get there. So the result of all of this is that we've had huge problems with being able to sell overseas. Scott just said premium shipping is done with dedicated flights and they only fly when they have a full load. Yeah, so it's really hit and miss at the moment. I've noticed with these PCBs, in fact, the PCB that we just did this reflow on came from China, and that was that was shipped. And when I got the shipping notification, DHL told me that it was going to be, I think it was 16 days was the estimated transit time from China to me on a service that normally takes 2 to 3 days. And then when they did actually deliver it, it took about 5 days, I think it was, or 6 days. So it seems to be really changeable. The carriers themselves can't predict what's going on. So all shipping time estimates are out the window. If your shipment happens to align with a time when there is a flight going and there is room and it can get on there, it can end up getting there really quickly. If there is no flight at that particular time, then you could be waiting weeks. Anyway, what this all comes down to is that a number of people that are doing online, that run online stores, have now had to turn off international shipping. And so that's painful. Coming all the way back to where this started was, that means there may possibly be a demand for more local manufacturing. And it's possible that there are people in Melbourne, for example, that want assembly done, and normally they would farm it out. Now, I'm not exactly a factory. I mean, you've seen what I've got set up here. It's a little lab with a DIY pick and place machine. Sion has a much better pick and place machine than I do, and he's been asked in the past as well about whether he would do contract assembly work, and he said no way. Doing contract assembly work opens up all sorts of difficulties, but maybe that's the sort of thing that is more of a future opportunity, is doing things really local. Okay, well, I've because of all of the screw-ups at the start, I've already been going for 2 hours. I'm going to stop in a moment, but I'm just going to quickly scan down for comments. Legion X asked, when will these be listed on the product page? When I've tested them. So we have a board now, and what I can do maybe later today, I'm not sure, sometime in the next few days, is I'm going to put the RJ45 sockets on it. I've also got to build the new version of the control panel board, which has got the display and the buttons on it. I've got PCBs for that, but I haven't assembled any of them. Hang on a second. I shouldn't be coughing in your ear like that. I need a more convenient mute button. And so once I've assembled boards, tested, I'm going to do videos about them and make them available. Okay, so Station 240 said, have you seen that through-hole soldering machine that Adafruit use? It's like a solder fountain. I haven't seen Adafruits specifically, but I've seen those machines many times. I've seen them in factories in China as well. I've seen a couple of them in use at Seed Studio. I've been to the factory that Seed, the little Seed Studio factory where they do their assembly in Shenzhen, and I've seen theirs running in the factory. So what Station 240 is talking about there is a soldering machine that's used for through-hole parts, and there are two different ways you can do it from the bottom of a board. You can either use a wave reflow machine, sorry, not reflow, it's a wave soldering machine, or you can use a selective soldering machine. So with wave reflow, the board is placed over a bath of molten solder, which brushes across the bottom of the board, and it solders all the joints that are exposed. The other way, which is what Station 240 is talking about, is like a solder fountain. The easiest way to imagine it is a chocolate fountain. So you've probably seen things where there is a tube up the middle and there is molten chocolate being pumped up, and it comes out the top and it streams down, and then you can stick marshmallows and fruit and things in it and coat it with chocolate. Well, imagine a chocolate fountain, but much smaller, and it has molten solder running through it instead of chocolate. And it's on a positioning gantry. So the PCB comes in over the top with the through-hole parts and the pin sticking through them, and then the reflow, or the soldering machine comes underneath, and it comes up and touches the joint, and the solder flows over it, and then the machine comes back down and moves to the next position. So it basically comes around and selectively solders different joints under the board. So Peter said, which PoE module did you use on Voltat? Oh, that particular one is just a super cheap 5-volt regulator module. This one here, I'm going to do a couple of different versions of that. Whoop, I'll spin it around and bring it up here. This particular version is for like a DIY PoE, where you put anything from 6 volts to 24 volts into it, and it will regulate it down to 5 volts and feed it to the Pi. Now, this black thing you see here, that is just a cheap 3 amp 5 volt regulator module that takes the unregulated power coming in from the correct pairs on the Ethernet connection, regulates it, and then feeds it back into the Pi. But it is not a proper 802.3 AF AT PoE system. It doesn't do any signaling or anything. It just expects you to be putting voltage onto the correct pairs of the wire. And so what I'll probably do is another version of this that has a proper PoE regulator module. I normally use the Silvertel modules, like the AG something, AG of course for silver. I can't even remember the part numbers. It's like 6112 is a 12 volt output module. There's an 8112, I think. So I'll probably do another version of this, which has support for proper commercial PoE for people that want that, which uses 48 volts on the wire. Okay. Oh, Station 240 said DHL 10 days to ship from Mousey, US to Australia. Okay, that's an interesting observation as well. That's the sort of thing that normally would take 2 to 3 days, and now it's 10 days. So, I mean, stuff is getting through, but slowly and unpredictably. Oh yeah, and Unexpected Maker said, I've been thinking about doing that, offering pick and place service, but it's such a tough thing to do. Yeah, it really is. There are so many considerations when you're doing a job for someone else and not just for yourself. When you do it yourself, there are so many things that you can make allowances for that that you can't get away with when you're assembling someone else's boards. There are things you can do in terms of testing and stuff that you can sort of fudge your way through, do it manually. But if you're assembling someone else's boards, then you need test procedures and all sorts of things. And Dodgy said, coming out of the other side of the shipping issues, people are still going to want to buy locally, even during good times. Stuff from China doesn't turn up after months of waiting. Yeah, that's true. Sometimes. And the other thing is that the cost of shipping out of China looks like it's going to be going up, and that was starting to happen right before the current crisis hit. And it began, I think, as a result of the US-China trade war that was going on. And I could go off into a long tangent about shipping out of China, but I'll resist that urge. But it looks like the days of free shipping on $1 items coming out of China might be over. We might end up having to actually pay for shipping. Aaron said, what about contract design? Well, yeah, that's a possibility, and I already do that. I have a number of clients that I do design work for. Those are typically commercial projects, and they are they're designs for a client that wants to own the rights, so I don't talk about it in the context of Superhouse. But that's actually how I make money normally, is doing designs for people. Espero Kali said, do you have to have insurance to do assembly work for people? Yes, and I pay a lot of money for insurance actually. There is insurance just for selling products as well. There is professional indemnity insurance, which is related to giving advice. Like if I tell a client to do something and then they do it and something goes wrong, I have liability for that, so I have professional indemnity insurance. And there is third-party insurance for damage if I make something and then it blows up someone's gear. So yeah, insurance. I already pay lots of insurance. Gorilla AU said, will we see more capacity for production being brought back onshore? That is the open question. I don't know. That's really interesting. There are very few places in Australia now where you can get contract assembly done. There are actually quite a few places that do it, but they only do it for themselves. It's like this little secret industry that happens behind the scenes. A lot of big companies that are in the tech space, like that deal with hardware, have their own pick and place machines. They have their own little assembly facilities, but they don't do work for anyone outside of themselves. They just provide, they just do work on their own products, and so nobody hears about it. There are places like Black Magic Design in Melbourne, who are fairly well known for doing all of their own assembly. So if you, they make camera equipment, and mixing desks and that sort of thing, like video mixing desks. And they run their own factory in Melbourne. But there are a lot of other places as well that do their own pick and place. For small runs, they might do a few hundred of something or a couple of thousand of something they need, and they do it locally. But no one ever hears about it. So in terms of a place that you can go and say, here is my design, please assemble this for me, I don't know, that might start to happen a little bit more. Oh, I'm going to get off soon, but I'll just try to answer a couple more of these. Espero said, are you introducing your kids to the things you know and teaching them? I give them the opportunity, but I don't push them. And the way I look at this is my kids have the opportunity to do whatever they want in terms of electronics work, but if they're not interested in that, there's no point pushing them. So just recently, actually, I've had my son doing some soldering work. He's been doing some SMT rework. There's a batch of boards that I got manufactured recently in China, and they put the LEDs on backwards. There are 9 LEDs on every board, and every single LED was fitted backwards, and they assembled 200 boards for me. The problem was that shipping them back to China and then getting them reworked and everything wasn't really worth it, and I figured I would just give Tommy the opportunity to do some paid work, and I set him up on the microscope, and he uses 2 soldering irons. So don't know if you can see it. Let's see, switch to the side view. There is this soldering iron here. Oh, you can't quite see it, but just over the other side there is there is the cord for a second soldering iron. So what he does is he works under the microscope with 1 soldering iron in each hand and puts 1 on each end of the LED and lifts it off the board. And then he puts new LEDs on, putting them on the correct way around. So yeah, and I'm paying him to do that. So my kids have the opportunity to mess around with this sort of stuff, and they've certainly done things like school projects that involve things that we've built. My daughter, who is now studying fashion design at uni, and I'm going to switch back to the front, it did a project where she put optic fiber through. She designed a couple of dresses and then put optic fiber and LEDs and things all through them. And the way we did that was I designed a custom controller with an ESP32. You might be familiar with the Adafruit Flora range, which are used for wearable electronics. I designed a version of a controller board that has an ESP32 on it, and we also wired up. So she did a whole lot of work under the microscope with putting 0603 resistors onto ribbon cable by scraping off the side of the insulation on the cable, like on a pair of cable. We actually used grey IDC cable, which is a 1.27 millimeter pitch, and we peeled it so that we had 2 conductors, and then she used a scalpel and sliced the insulation off it, and then under the microscope she put 0603 resistors across the ribbon cable between the 2 conductors, and then we put all of that through the dresses that she designed so that they would glow at night. So to answer the question, kind of anything that they want to do I will help them with, but I'm not saying you must do tech stuff because their interests aren't necessarily there. Oh yeah, and Scott said, Tommy is at least as smart as his dad. Yes, he is. So, Vanquisher asked, what are you using for the 240 volt switching side of your home automation? I will answer this question very briefly and then I'll cut it off because it's now heading towards 2.5 hours. So two different things. I have son-offs for things like power plugs, things like control of my soldering iron and the exhaust fan in here, which I control through She Who Shall Not Be Named, are done using Sonoff S55s. So that's the little plug that you put into a power point and then you plug something into it and you can turn it on and off. I really like those because they are portable and you can retrofit them to anything. So if you've got like a bedside lamp and you want to make it controllable, you just plug it in, 30 seconds later you're ready to go. The other part of it is my entire house has been rewired from scratch. So I have centralized switching of my of all the loads in my house. Now what I'm going to do is drop a URL for a video that I did specifically about this that will help explain a bit more. There is the, oh wow, how far back do I have to go? Is this the one? Yes. Okay, so what I have is central switching of all the loads in the house, and this particular episode explained how I did it. What I have is switchboards full of relays that turn things on and off. So loads around the house, like lights, are not controlled by the switch on the wall. They're controlled by the relay in the switchboard, which then has the wire that runs all the way to the light. Cool. Alrighty. Now I am going to cut it off there, and I'm going to try not to feel bad about it. I want to keep talking about this stuff, but now that I'm doing this regularly, it's every Sunday I'm doing a live stream. It means I can cut it off at 2 hours and not feel bad because we'll be back. We can answer more questions and talk about more things next time. But what I'm going to do is drop a URL in here, and if anyone wants to chat about stuff, come and join Discord. And there are a whole bunch of people in there that are very happy to talk about these things and help you with your home automation projects or whatever else it is that you want to build. One thing I will point out, because this is it's caught many people, there is a permissions thing in the Discord where if you sign up for it, you can't see all of the content until you go into the rules channel. And there is a post there with the rules, and you have to give it a little thumbs up. So click the thumbs up that other people have already done, and the bot will then give you access to everything in the Discord. So when you first join it, you might think it's empty, there's nothing here, and you can only see 2 channels. Once you accept the rules, you'll see there are dozens and dozens of channels on all sorts of topics. So come along and say hi. So thank you very much for coming along to the live stream again, and it is very cool to have so many people here and answer questions and talk about stuff. What I really want to do is get someone else maybe helping me. In fact, maybe next week I'll get Tom or Amelia to act as my producer, and they can read out questions and change screens while I'm doing stuff. So that is all for me. So thank you very much. See ya.